Is it visible? See? Okay. With animation. So that way we talk about the thermal conductivity of insulating material, correct? And its unit is watt per meter per Kelvin. And its unit is also watt per meter per degree Celsius. So we discuss all those. नहीं आता लेक्चर है थोड़ा वेळ. अच्छा. Now we also talk about the governing equation of convection. So Newton's law of cooling that we applied for this, and we come to know that H is heat transfer coefficient and its unit is watt per meter square per degree Celsius. We also talk about the radiation, and Stefan Boltzmann law is used to govern this equation. So heat flux is directly proportional to the fourth power of its absolute temperature. So sometimes they may use here P, or sometimes it is Q, that is heat transfer rate. Someone is coming late again. So Q upon A, and that is nothing but the heat flux. Sometimes this one is called heat flux. Instead of only Q is a heat rate, and this one is heat flux. Heat transfer per unit area. So heat flux is directly proportional to the fourth power of its absolute temperature, and when we replace that directly proportional sign, it is equal to sigma T raised to 4, and this one is calculated, and this value is 5.67 into 10 raised to minus 8 watt per meter square per Kelvin raised to 4. Now, Stefan and Boltzmann both are different scientists, and both develop this, find out this constant sigma 5.67 into 10 raised to minus 8 watt per meter square per Kelvin raised to 4 independently. And that is why its name is Stefan Boltzmann law. Here, these things we had learned in a previous lecture. Now we concentrate on the one-dimensional heat conduction equation with internal heat generation for plain wall. Now, for plain wall or plain slab, for cylindrical shape, for spherical shape, etc., etc. Now, one-dimensional, that means heat is flowing only in one direction. Suppose there is X, Y, and Z. So what happened with that? You want to convert it only in X direction. You did what you did in Y direction, positive Y direction and negative Y direction, positive Z direction and negative Z direction. You apply the insulator, and then heat is flowing only in X direction. That is called one-dimensional heat conduction. Now here, not only one-dimensional heat conduction with internal heat generation, and that is also important. So first of all, a standard object is plain wall. So what is that plain wall? This is the one case. You can see that the one of the primary direction of heat transfer over here, and this is one of the like this structure. Okay, it has some thickness, and rest of the part, that means heat is flowing this direction. If I take it outside, whatever that glass or something, and I draw its view, it will be like this only, right? So heat is flowing in this y direction. Heat is flowing in this z direction. Heat is flowing in this x direction. Now in this case, as it is a plane wall, what is the difference? What is the definition of wall or plane wall? What do you think? Any object which has very less thickness as compared to its length and width, that is called plane. You learn in engineering graphics. What is a plane? A object which has very negligible thickness as compared to its length and width, that is called a plane. So here is one of the plane, or you can say one of the mirror, and here in this z direction, as its thickness is negligible, and in y direction, as its thickness is negligible, heat is flowing is in negligible value, and therefore we consider that with this glass only x direction. So this is the example of one-dimensional heat conduction. Now, not only that, here internal, if one of the heater is located inside of this wall, then what happens? Internal heat generation over there, right? Now, in that case, how the heat is flowing in x direction, positive and negative direction. So that thing we have to consider in this case. So this is the best example of one-dimensional heat conduction equation. So is x direction, okay, this one is y direction, this one is a z direction, right? Now heat is flowing only in x direction, right? With what? With internal heat generation. So you can say that here internal heat generation per unit volume, right? Now here, consider a thin element of thickness delta x. So this thickness is delta x. Okay. If I use this thickness of this plane wall, that one is delta x. Or you can say dex, right? Try to understand. Difficult to write with this, but otherwise I can draw very well. Okay, dx, right? So consider a thin element of thickness delta x in a plane wall, and after that you have to make some of the assumptions. What are the assumptions? Assumptions are that the density of the wall is rho, okay, and that is constant. Then specific heat is a C, okay, of this wall, and the area of the wall normal to the direction of heat transfer is A. As I told you in a Fourier's law, Q is equal to minus K into A into dt by dx. I have told you which area we consider? The area which is perpendicular to flow direction, and that area we always consider. So here the area of the wall normal means perpendicular to the direction of heat transfer is A. Okay. Now, so first one, rate of heat conduction. I again show you that diagram here. Here the heat is coming from x direction, so that one is Qx. You can see in the diagram. passed from this stream, the heat is what? Qx plus delta x, right? So here I can write the equation: rate of heat conduction at x, correct, minus rate of heat conduction at x plus delta x plus what? The rate of heat generation inside the element is equal to what? Is equal to rate of change of energy content of the element. Are you getting my point? Is it okay? All of you? Is it okay? Shall I explain you again? Is it okay? Is it okay, or shall I explain you again? Am I audible to you? Okay. Someone said, Samir, repeat. Okay, fine. Here, this is the diagram. Now, total heat coming at x direction, correct? And total heat coming out from this x plus delta x direction, correct? Because this is a delta x, and up to this x, and after that, this one is x plus delta x at this stage, right? So, total heat come in and total heat out, right? So Qx, if you apply steady flow energy equation over there, so total heat come in minus total heat taken out plus total internal heat generation. So internal heat generation over here, E dash, or sometimes E dot, or sometimes E dash is given, or somewhere E bar is given, sometimes small g is given. So these are the standard notation used for internal heat generation. So here you can see E dot, that is E generation, and volume of this element is this one, right? So I can say that by applying the steady flow energy equation at x, where at x the rate of heat conduction at x minus the rate of heat conduction at x plus delta x plus the total internal heat generation, rate of heat generation inside the element. It may be a nuclear reactor, it may be a wire which is insulated. So when the electric wire is over there and the current is flowing through that, the heat is generated, because we know that Q is equal to I square R. As I value is more, the resistance is more heat generated within that the wire. So rate of heat generation inside the element, so it may be nuclear reactor, it may be furnace, it may be crucible over there, it may be the wire, which is the wire, electric wire through which the current is flowing. So rate of heat generation inside the element is equal to total internal energy change within that stream. So that is rate of change of energy content of the element. So this is the theoretical thing. Now mathematically, how do you write Qx? So though Q dot x is nothing but rate of heat conduction at x, then minus, then Qx plus del x is nothing but the rate of heat conduction out of that stream, that is Qx plus del x, then plus, and after that rate of heat generation, as I said, somewhere E dot, somewhere G dot, and all. So G dot element is equal to now rate of change of internal energy of the content. What is, how do you say that? How do you identify? Quick formula: mCp delta T, mass into specific heat into temperature difference. So that temperature difference with respect to small time t. But when it is unsteady state, then we have to write small time t, that is nothing but time. Okay, and If it is a steady state, then mCp delta t. So here it is a small time t delta E element by delta t. Again, I explain in a better fashion change in energy content of the element. So type equation here, I can write delta E is equal to for delta E plus T into delta T, correct, minus delta Et. So this one, this value change with respect to time. I can write here delta E is equal to delta E plus delta time T. If you consider this heat in, heat out, internal heat generation for very small time interval, and that is nothing but delta T. So with this time, I can say that whatever the internal energy change, that is delta E small time plus delta small time t minus delta Et, and that one is here equal to what? mCp t plus delta t minus Tt. As I told you, internal energy is mCp delta t when it is steady state. But if it is not steady state, then I can say that mCp delta t by small time t. So this is the case. But in general, we always consider that it is steady state. But for this equation, we can say that it is initially this one. So delta E is nothing but mCp delta T. And then is equal to what? mCp, so rho Cpa into delta X. How do I write this one? Because we know that what? Density is equal to what? Yes? Rho Cp into A. So volume, yes, density is equal to mass upon volume. So I can write here what? Mass is equal to rho, that is nothing but density, and volume. Volume is what? Area of that strip into thickness, that is nothing but volume. So I can write here volume is area into small thickness del X, and that is nothing but mass. So I can put this value here, right? Instead of m, I can write rho into area into del X. Get it? So next one is then time delta T minus this one, right? Now the rate of heat generation within the element can be expressed. How it expressed? It is expressed G dot element is nothing but per unit volume. Okay, it is per unit volume. So G dot element is equal to total internal heat generation into volume. So volume, we know that area into del X. Therefore, I can write the G dot element is nothing but small g into volume, and volume is area into small strip thickness del X. Get it? And after that, put equation 2, equation 3 in main equation number 1. All of you do it now. And then you come to know that Qx minus Qx plus delta X into G area into del X is equal to rho Cpa. Rho Cpa del X T capital T small time t plus delta t minus capital T at t divided by small interval time delta, right? Which I stated in explaining equation number 1, 2, 3. Again you can see, again simplify this. You come to know that Q dot X plus Q dot X del X plus G into A into del X rho Cp A d delta X delta time t or temperature difference dividing by delta time t. So that one is equation number 4. Now divide the equation 4 with the volume. And so volume is area into del x. So when we divide it, you will have minus 1 upon a q dot x plus del x minus qx upon del x, correct? Is equal plus d, because if you divide with the area with all equation, area into del x. So again, area into del x. For your simplification, I am doing this. Some of my friends are like me, they don't know much more about this one, so they will get the d or del x, both are same. So you can see this is gone, you can see this one is gone. So whatever left, right, whatever left, that we can set it, right? So minus 1 upon a q dot x plus del x minus qx upon dx plus g into rho c p, or sometimes it is called specific heat at constant pressure Cp, specific heat at constant volume Cv. So we use rho Cp, that is specific heat at constant pressure. So rho C into delta T upon T. Correct? So this is equation number 5. And then taking the limit as del x tends to 0, delta T goes to 0. Okay? So here it is very, very important. Taking the limit as del x is equal to del x tends to 0, delta T is also tends to 0. Now if that happens, then we have what? 1 by a dabba by dabba x into ka dt by dx minus g rho cp dt by dx. How do you say that it is happen? Any clarification for this? Yes? Any clarification for this? From the definition of derivative and Fourier's law of heat conduction, I can say that what limit limit delta x tends to 0, in that case q dot x plus del x minus q dot x upon del x is equal to dabba q by dabba x, and then because of the definition of the derivative, mathematical formula, definition of the derivative, and that is mathematical formula. So q dot x plus del x minus q dot x upon del x is equal to dabba q by dabba x is equal to dabba by dabba x. So q, what is q as per the Fourier's law? Q is equal to what? Minus k. Minus k into a, actually small k, huh? Minus k into a into dabba t by dabba x, and that is nothing but Fourier's law. So instead of q, I can put this value, and this happens. Why q? Because of the exact definition of the derivative, right? So I can write here, what I can write here, the dabba by dabba x into k dt by dx plus g dot is equal to rho cp dt by dt. Correct? Any doubt with this? Any doubt with this? If I put it here in this equation, what I can put? A cancel, right? So I will have dabba by dabba x, right? Small k, right? Dabba t by dabba x, okay? G rho cp dt. So delta T by delta small time t. Any doubt with this? All these equation. Any objection for this? Yes? Any objection? All of you? Any objection? Understand? You understand it? Because it is very simple. After that, we can derive one of the formula for three-dimensional heat conduction equation. Once it is easy for you, then it is really understand. Then only you can go here. Is it understand, or shall I go here again? Repeat it again. Yes, please give me your concern. Hello? Am I audible to you? Sean?
Yes, sir, audible.
Yes, audible. Tell me your concern, whether I will repeat it again or go ahead.
Sir, you can go ahead, sir.
Okay, thank you. So this is the case, delta by delta x into k dt by dx plus g dot is equal to rho c into dt by delta t. Okay, now this is equation number 7, and it is very easy, and that's why I'm explaining you the thermal conductivity. Now here K, that is nothing but the thermal conductivity K of material in general depend on the temperature T, which we had seen in the previous lecture, that for the solid thermal conductivity there are two mechanisms, lattice vibration and free electron. For the metal it is inversely proportional with the temperature, thermal conductivity K, and for the non-metal or insulator the thermal conductivity is directly proportional with temperature. That I explained you very well. So here the same concept, thermal conductivity K of material in general depends on temperature T, and therefore the thermal conductivity in most practical application can be assumed to remain constant, okay, at some average value, okay, and therefore assume that it is constant. Now hence it is constant, then you can write as per that equation. So as K is constant, so you can divide, right? You can see that here, you can divide throughout with dk. So when we divide equation number, which one is equation number 7? See the yellow strip equation number 7. Divide it throughout the k. So left hand side and right hand side, then you will have delta square t by delta x square plus g dot by k is equal to 1 by alpha delta t by delta small time t. Now delta square t by delta x square. Now here it is only in one direction. So partial differentiation convert into exact differentiation. So here we can write d square t by dx square instead of delta, because it is not a partial, it is a fixed in one direction, and that is x. So partial derivation convert into exact derivation, that is delta square t by delta x square plus g dot by k is equal to 1 by alpha delta t by delta small time t. Now here the alpha, that is nothing but thermal diffusivity. What is that? Thermal diffusivity. So here the property alpha is equal to K upon rho C. So it is the thermal diffusivity. What is thermal diffusivity? Thermal diffusivity of the material represents how fast the heat propagates through that material. So more the thermal diffusivity, more heat flow through that, because the thermal conductivity is very high. Here you can see alpha is equal to, or if I replace that proportionality sign and if I consider density is a constant, specificity is constant, I can say that I can say that yes, student, am I audible? Am I audible to you?
Yes, sir, audible.
Sorry, because of some technical issue, the light is off and it is automatic. So, sorry for this. Screen is visible to you? Shared screen is visible to you?
No, sir. Yes, sir, now it's visible.
Can you see this? Thermal diffusivity of material.
Yes, sir.
Okay, fine. Shall I continue?
Yes, sir.
Okay, thank you. So here, that is important, and that one is if alpha is a thermal diffusivity, and I replace the proportionality sign, so you can say it is a directly proportional. This is alpha and this is proportionality sign. Okay, directly proportional to K if rho and C both are constant. So more the thermal conductivity, more will be the heat propagates through the material. So the material which has high thermal conductivity, through which the heat is propagated very fast. This is the conclusion. Next, equation 8. So here equation 8, this is the final equation, gamma square T by gamma x square plus G dot by K is equal to 1 by alpha gamma T by gamma small time t. This is final equation. Now you have to reduce this equation in a different forms. Okay, so that is equation 8 reduces the following form under specified condition. Which are the specified condition? This is the specified condition. Okay, so this one steady state. Now when it is a steady state, Again check equation number 8. When it is a steady state, that means this value, the change of temperature with respect to time. This is a temperature. And this small time t is time. So when it is a steady state, what happens? This value is 0 because it is not changed. So what will be the condition? The condition is here. So steady state gamma t by gamma small time t, that goes to 0 of the right hand side of equation number 8, and therefore this equation becomes d square t, because partial derivative convert into exact derivative, d square t by dx square plus g bar or g dot, small g dot by k is equal to 0. And this reduction, when we consider steady state over there, it's called Poisson's equation. So they may ask you, derive three-dimensional heat conduction equation for Cartesian coordinates, for plane wall, for a slab, etc., etc., and reduce it to or three standard form: Poisson's equation, Fourier's equation, Laplace equation, etc., etc. So second one, transit. What is transit? No internal heat generation, right? So no internal heat generation means that particular in equation number 8. Again, equation number 8. You can see G dot, that is 0, right? And this one is that. Transit means what? The temperature change with respect to time continuously. There is no steady state. That is nothing but transit. So here you can see that transit is this one, right? And there is no internal heat generation. So this equation, equation number 8, transfer into gamma square t by gamma x square plus 1 by alpha, that is nothing but 1 by thermal diffusivity, into change of temperature with respect to time, that is gamma t by gamma small time t, and that equation is nothing but Fourier's equation. After that, they said that steady state is there. That means what? Steady state is there means what? This one with no internal heat generation. So steady state as well as no internal heat generation. So this one is 0. Along with that, G dot is also 0, right? And therefore only d square t, so that gamma square t by gamma x square convert into exact derivation, and therefore this one is d square t by dx square is equal to 0. That is a Laplace equation. Sometimes they use this term over here, gamma square t by gamma, like this. Okay, so gamma x square. So don't confuse. जास्त सांगण्याच्या नादात confuse व्हा. So this is the case, and therefore one dimensional heat conduction equation for long cylinder मी नंतर घेतो, कारण ते जास्त महत्त्वाचं नाहीये, पण हे जास्त महत्त्वाचं आहे. Any doubt with this? Any doubt with this? Now आता तुम्ही जे काल मागच्या लेक्चर मध्ये तुम्हाला एक लिंक दिली होती, ती लिंक कॉपी करा आणि आता सॉल्व करा. ठीक आहे, परत काढतो बघा. Just wait, just a minute.